In this video, let's take a look at a one-sample hypothesis test for proportion when we're doing the right-tailed test. In this example, we have a sample of 112 mortgages that were approved during the current year, and it showed that 32 were issued to a single earner family or individual. The historical percentage is 24%. So we can test then at the 0.05 level of significance in a right-tailed test to see if the percentage of a single earner or individual mortgage has risen or increased. So we know it's a right-tailed test because we're looking to see if it's increased. Given that information, we can set our null hypothesis, which will be that pi is less than or equal to pi naught. And our alternative hypothesis then will be that pi is greater than pi naught. In our problem, we're given the alpha value of 0.05. The pi naught was the historical percentage of 24%. Our sample size was 112. Of those, we had 32 that were single earners. So our p-value then is going to be B21, which was our x value, our 32, out of 112 in our sample size. Now I've set this up to always round to 2 decimal places. So that's going to be useful in our calculation when we're dealing with proportions. For the z-table, we're going to calculate our norms inverse for cell B18, which was our alpha value. And we're looking at the right-hand side. With this function, we'll have the negative in front of it. So negative norms in for B18. Our t calculation will be calculated using our z statistic. We're going to take our value for p, which is cell B22, minus our pi naught of B19, and divide that by the square root of pi naught multiplied times 1 minus pi naught over our sample size of n. That gives us a value of 1.2390. So when we look at our calculation, we have our z-table, which would be a value of 1.645, our t-calc, which would be 1.2390, so we know that we're going to fail to reject our null hypothesis. We can set that up as our conclusion as well by comparing our value for B24 for our t-calc. If it's less than B23 from our z-table, then it will fall in this fail to reject region. So we'll have the conclusion of fail to reject H naught. Otherwise, we would reject the null hypothesis. So our conclusion here is correct. We can also calculate our p-value, which is 1 minus our norm.s.dis distribution using cell B24, which was our t-calc, and then we'll use a 1 for cumulative. So our p-value then is 0.1077. It's greater than our alpha value of 0.05. So it shows us that we don't have quite that level of confidence within our results, but we can conclude with almost 90% confidence our results. We can also look to see if our normality assumption is justified from our equation. With our normality assumption, we're going to start by taking our n times our pi naught, which gives us a value of 26.88. And then we're going to use n times 1 minus pi naught, which gives us a value of 85.12. To know if our normality assumption is justified, we want to make sure that our value of n minus pi naught is greater than 10, and that our value of n times 1 minus pi naught is greater than 10. Since both of these numbers are greater than 10, our normality is justified. So we made a correct assumption of normality for our data.